Hi everyone, today we are going to identify key features about polynomials including zeros, multiplicities, degree, and behavior and local extrema. For the do now, it says which of the following polynomials does not have degree 4? So take a look at the answer choices. If you notice, there's a 2 and a 2, so we add them together to get the degree, so that's degree 4. 2 and 2 again, degree 4. This one has 1 plus 2, which gives us degree 3, and 1 plus 3 gives us degree 4. So the answer choice would be choice 3. That does not have degree 4. Number 2, state the number of real roots and the number of imaginary roots given the equation f of x is equal to x cubed plus 3x squared plus x minus 5 and the graph shown. So if you notice on the graph, it only intersects the x-axis once, which means there's one real root. Because the degree is 3, I know I'm going to have 3 total roots. So if I only have one real, that means I must have 2 imaginary, so it has to be choice 3. Again, 3 total roots, only one of them intersects the x-axis, so only one of them is real, therefore 2 are imaginary, and remember, imaginary roots come in pairs. Number 3, for the following, identify whether the function graphed has an odd or even degree and a positive or negative leading coefficient. Well, if we look at this, we notice that it's increasing, so we know it has a positive leading coefficient. And then the arrows are pointing in different directions, which makes it odd. So it's odd, and the leading coefficient is positive, choice 4. Let's take a look at the next page. Example 1, use the picture at the right to answer the following questions. A, classify each zero of the function below with its multiplicity. Okay, let's see. So here, when x is equal negative 3, it has a bounce, so it has a multiplicity of 2. Here, when x is equal to 2, there's a squiggle, therefore the multiplicity is 3. Here, it goes straight through at x equals 5, and therefore the multiplicity is 1. How many total zeros are there? We're going to add our multiplicity, so 2 plus 3 plus 1 gives us 6. However, C says how many distinct zeros are there? What distinct means is unique. So there are only 3 distinct zeros at x equals negative 3, x equals 2, and x equals 5. We're going to write down the possible equation for this function. So it's going to be y is equal to, since my 0 was x equals negative 3, we're going to change the sign and do the opposite, x plus 3, and then our multiplicity is the degree, which is squared. When x is equal to 2, we're going to do the opposite, x minus 2, the multiplicity is 3. And then when x is equal to 5, x minus 5, the multiplicity is 1. What degree could this polynomial function have? Again, we're going to add the exponents. 2 plus 3 plus 1 is going to give us 6. And notice that the arrows are pointing in the same direction, which makes it an even function with a positive leading coefficient. Even positive leading coefficient. The next example, example 2, is the graph below an odd degree polynomial or an even degree polynomial? Explain your answer. So what we're going to look at is the arrows. So notice that the arrows are both pointing up. So that means it's an even degree. So even degree because the arrows are in the same direction. It also has a positive leading coefficient because they're both pointing up. Next, in example 3, the graph of p of x is equal to x cubed plus x squared minus x plus 2 is shown below. Use the graph to determine the following. What's the degree of the function? Well, if we look at the equation, my highest degree is 3, so it is 3. The number of real roots, let's take a look at the graph. Notice it goes straight through at x equals -2, so there's only one real root. And because there's only one real root and we have a total of degree of 3, we have to have 2 imaginary roots. And remember, our imaginary roots come in pairs. Our total number of real roots plus the number of imaginary roots has to equal our degree. In example 4, given the graph below, answer the following questions. The number of local extrema, which are turning points. So I'm going to circle our turning points. So we have 3 total turning points. Now our lowest possible degree of the function is 1 more than the number of local extrema. So it's really going to be 3 plus 1, which equals 4. So that is our lowest possible degree of the function. Next, example 5. Look at the picture shown below and answer the following question. So let's look. Here we have at x equals -2, we have a bounce. So that has a multiplicity of 2. Our minimum is here, our maximum is here, and here at x equals 3, we go straight through, which means it has a multiplicity of 1. Now the first question says A, how many distinct zeros are there? Remember we said distinct means unique, so there are only 2 distinct zeros at x equals -2 and at x equals 3. State our zeros, our x-intercepts, and their respective multiplicities, which we already did. X is equal to -2, the multiplicity is 2, and at x equals 3, the multiplicity is 1. How many total zeros are there? We're going to add our multiplicity, so 2 plus 1 gives us 3. We're going to write our possible equation, y is equal to, since our 0, x equals -2, we're going to change the sign, so x plus 2, our multiplicity is squared. And then at x equals 3, we change the sign, x minus 3, our multiplicity is 1. The degree of the equation you wrote is 2 plus 1, which is 3. And then which direction are the arrows pointing? Should it be an even degree or an odd degree, and why? So let's scroll back up. Notice the arrows are pointing in different directions, so that therefore it's an odd degree. Arrows are not in same direction. And it would be, let's see if it would be a positive or leading coefficient. It would be a negative because it's going down. Thanks for watching.